بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Calculus 2 and first major term 2 to 1. So let us solve it together. First question, express the integral as a limit of Riemann sum using right endpoints. Do not evaluate the limit. So the definition of the definite integral says the integral from a to b of f of x dx is equal to limit when n goes to infinity of summation I from 1 to n f of x I delta x. That's the definition of the definite integral, where delta x is b minus a over n. So here b is 5 and a is 1. So delta x will be in fact 4 over n. So the integral in the question, which is from 1 to 5, the function f of x is square root of 7 plus x cubed. So this definite integral can be written as a limit of Riemann sum using this definition. So limit as n goes to infinity, summation I from 1 to n. Well, f of xi would be square root of 7 plus xi to the power 3, and delta x is 4 over n. So this would be the expression needed. 4 over n, you can take it outside the sum or leave it there. Both are correct. Question 2, evaluate this integral by interpreting it in terms of areas. So using geometry. Well, first I will divide the integral into two integrals using the fact that I can distribute the integral when there is a sum. So I have two integrals, integral of 2 dx and integral of square root of 25 minus x squared dx. Well, the first integral, 2, here the function is y equals to 2. And the graph of this function is a horizontal line. This is the line y equals to 2. And from -5, if I say that this is -5, this is 0. So we need this definite integral means the area below the function y equals 2 and above the x-axis from -5 to 0. So it's in fact the area of this rectangle. And the area of this rectangle is the width times the length. So the distance from 0 to -5 is 5. You can see that this is the length of the rectangle times the width. This is 2. So from 0 to 2, that's 2. This is in fact 2. And this is in fact 5. So the area is just 10 square units. While the other function, I have y equals square root of 25 minus x squared. And to find out what this function is, I square both sides. And then I take x squared to the other side. And then I realize that this is a circle. Circle with center at 0, 0, and radius 5, square root of 25. So if this is 5, I have this circle, okay? But I need, it is not the circle I'm sketching, it is this function, and y is positive. So the graph in fact is here when y is positive above the x-axis. But I need to find the area below this curve and above the x-axis from -5 to 0. So in fact, I do not need this part. So this part is the one I'm talking about. So in fact, we need this area, the area of this region. And this is a quarter circle. Well, what is the area of the circle? The area of the circle is pi r square, so pi. And r here is the radius, and it is 5. So 5 square is 25. And we divide by 4 because we need only a quarter circle. So the final answer would be 10 plus 25 pi over 4. That's the correct answer. Okay. Write this integral as a single integral in the form a to b. We have a property of the integral that if we have integral from -2 to 2, then plus 2 to 7, these two integrals, in fact, I can immediately write them integral from -2 to 7, okay? F of x dx. That's a property. When you have a to b, b to c, then you can write it from a to c. And now we have this integral, which is from -2 to -4. Well, I need -2 to be here, down and up. Also, you can, if you want, you can sketch something like this. The first integral is from -2 to 7, while the second integral is from -2 to -4, so -4 is here. So if I want to write it as a single integral, I will write it from -4 to 7. That's why I need to switch the limits of the second integral. So I can write it from -2 to 7, f of x dx, plus, when you switch the limits, you change, multiply by a negative sign. And now you can write it, if you want, you can just write the answer, or you can write this integral first. So this is from -4 to -2, and the other one is from -2 to 7. So finally, you can use the property and write it from -4 to 7. So this would be the answer of the question. Set up an integral only. So just set up an integral for the area of the shaded region, bounded by these three curves, two lines and this parabola. So it's the blue region here. So we have the graph. We need to find the area. Well, to find the area is either the area is the integral area between two curves from a to b, the function in the top minus the function above minus the function below, and the integral would be with respect to x. If you have a function above another function. So if you have a function like this, and you need to find this area, you use this rule. Also, if you have a function right to another function all the time, but to find this area, you can use another formula. But in this case, here we are going to use a typical vertical rectangle, but here I'm going to use a typical horizontal rectangle. So the width of this rectangle would be dy. So in this case, y will run from c to d, and I have to write the functions as functions of y. So x1 would be f of y, x2 would be g of y, and this would be the area. So actually I can find either a vertical typical rectangle or a horizontal typical rectangle in this case. So let me solve it in both methods in your sake of understanding and applying concepts. If I choose a vertical rectangle, we notice that this region up to this line, when x is 1, okay, this rectangle, when you move it, when you move it right and left, always the line, this line, 3y equals 2x plus 16, will be above this curve, y equals x squared. So I can find this area using the first formula here. Okay? And the width of the rectangle is delta x. So the area would be integral from, well, I'm working with dx with respect to x, the width of the rectangle. So x runs from, x here is -2 and x here is 1. So from -2 to 1. And f of x, the function above, which is this function, and it has to be y equals f of x. So it is, but I have to divide by 3. So 2x plus 16 divided by 3 minus the other function is this function, the parabola. But it has to be y equals g of x. So it is, so x squared. So this will give me the area of this region. I can call it A1, for example. Then I need to find the area of the second region. I'll take a vertical rectangle like this, and I'll use dx, okay, because the width of the rectangle, it's a vertical rectangle, the width is delta x. And now x runs from where to where? From 1, here x is 2, so from 1 to 2. The function above in this case would be this line, which is y equals -2x plus 8, okay, minus the curve, which is y equals x squared. So this would be an answer. Or if I want to use a horizontal rectangle, I can also use a horizontal rectangle and solve the question again in another. So both solutions are correct. So if I use a horizontal rectangle, okay, I notice that this horizontal rectangle, always this part of the curve of the parabola, the right part of the parabola, will be to the right of the left part of the parabola. But up to where? Up to this line, the line y equals to 2. Because after that, I'll have something different. I'll have this curve, which is this line, to the right of this line. Okay, to the right of this line. So also, if I use a horizontal rectangle, I have to divide the area into 2 parts. Let us start by the one here below, this region. Okay, let us find the area of this region. Well, here I'm using a horizontal rectangle, so the width is delta y. So I need to use delta y. Okay, y runs from where to where? Well, y here is 0 up to 4. Okay, so y is from 0 to 4. The function to the right minus the function to the left, but it has to be x equals. So the function to the right, now I have y equals x squared. I need it to be x equals, so x would be plus or minus square root of y. In fact, this right part of the parabola has the equation x equals square root of y because x here is positive, while this part has the equation x equals negative square root of y. So the function to the right is square root of y minus the function to the left, which is minus square root of y. So this would be the first part. Okay, let us write dy here. Plus. Now the area of the second region, this region, which is a triangle, again, horizontal rectangle, so dy, and y runs from where to where? From 4 up to 6. So from 4 to 6. And now this curve this line is to the right of this line. So I need it to be a function of y. So I need to solve it for x. So negative 2x would be y minus 8, and x would be y minus 8 over negative 2. So y minus 8 over negative 2 minus the other curve, but I need it to be solved for x, which is a line again. So x is 3y minus 16 over 2. 3y minus 16 over 2. Just take 16 to the other side and then divide by 2. So that's the answer. And you can simplify the second integral. You can write it from 0 to 4. This is square root of y plus the square root of y. So in fact, I have 2 square root of y. And also I can simplify these two. If I say it is y minus 8, let me take the minus up. So it's minus y plus 8 over 2 minus 3y plus 16, because the minus will affect the two terms both over 2. So negative y plus negative 3y, that's negative 4y over 2. That's negative 2y. And 8 plus 16, 24 over 2, that's 12. So I can write the second integral like this, okay? And you can check by the calculator. You know how to use the calculator to find a definite integral. Check that this integral and this will give you the same answer. Evaluate the following integrals. Well, here I have integral, definite integral of, I can separate, I can distribute, there is a minus sign. Also, I can take 3 outside, okay? So what is the integral of EX? We know that the integral of EX is just EX. Okay. So this is a definite integral. So from 0 to pi over 4 minus 4 secant tan. What is the integral of secant tan? Just secant, because the derivative of secant is secant tan, from 0 to pi over 4. So I'll have 3, then multiplied by e to the power pi over 4 minus e to the power 0, which is 1, minus 4 times secant pi over 4. And you can find by the calculator cosine pi over 4, which is 1 over square root of 2, and then find 1 over, okay? So it would be square root of 2 minus secant of 0. Well, it is 1 over cosine 0. Cosine 0 is 1, so it is just 1. So the final answer would be 3 e pi over 4 minus 3 minus 4 square root of 2 plus 4. So I can write it as 1 minus 3 plus 4 plus 3e pi over 4 minus 4 square root of 2. That's would be the answer. Now the next question. The next integral. Well, I have x squared minus 1 over x to the power 4 minus 1. Well, if you think of substitution, the derivative of x4 minus 1 is 4x cubed, and I don't have it up. Well, what can you do? If you think of distributing, right, x squared over x4 minus 1, it doesn't solve anything. So there's no way to solve this integral by substitution. But if you notice, I have x squared minus 1 and x4 minus 1. And in fact, I can factor, I can simplify this integral first. x to the power 4 minus 1, I can use the formula difference between two squares, a square minus b square is a minus b times a plus b. I can write this as x squared minus 1 because 1 is 1 square times x squared plus 1. And now I can cancel this with this. And once I cancel, I'll have up 1 in the numerator over x squared plus 1. And the integral of 1 over x squared plus 1 is just tan inverse x. So it's now easy to evaluate. Then I'll have tan inverse 1 over square root of 3 minus tan inverse 0. And tan inverse 0 is just 0. You can use your calculator to find tan inverse 1 over square root of 3, but make sure that you are in radian mode, and the answer would be pi over 6. Okay. Now, how can we solve this integral? I have secant square over tan square. Well, what do I know about the derivatives? What is the derivative of tan? Derivative of tan is secant square. Okay. So can I take u using substitution here as tan x, only tan x? What would be du in this case? It would be derivative of tan, which is secant square x dx. Well, then this integral would be changed to secant square x dx is just du. And in the denominator, I have tan square, but tan is u, so I'll have u square. And now it is easy to evaluate. I can take u square up. Then I add 1, u minus 2 plus 1, which is u to the power minus 1 over minus 1 plus c. That's the formula. That's the integral. The integral of x to the power n dx is just x to the power n plus 1 over n plus 1 plus c. So I'm using this formula. And then u is just tan x. I can bring it also down. Can write this as negative 1 over u plus c, because u minus 1, you can bring it down. So the final answer would be negative 1 over, and u is tan x plus c. You can leave it like this, or you can write it negative cotan if you like. That would be the answer. Well, to find this integral, I need to expand, because the integral, the definite integral, or the integral in general, you cannot distribute the integral if you have products, only if you have plus or minus. So it would be from negative 1 to 2. Now, 3u times u would be 3u square. And here I'll have negative 2u, that's the inner terms, and the outer terms will give you 1 times 3u, 3u. And then you combine these terms, 3u minus 2u, and you get 1u. And minus 2 times 1 is negative 2. So you have to find this integral. And this integral is easy, because you can use this formula again. Okay, so the answer would be 3 u cube over 3. You can take the 3 out because it's a constant, plus the integral of u is u to the power 2 over 2 if you add 1 to the power, and the integral of negative 2 is negative 2u from negative 1 to 2. Okay, so here 3 cancels with 3, so I'll have 2 to the power 3, which is 8, plus 2 to the power 2, that's 4 over 2, that's 2, minus 2 times 2, so minus 4, minus, I replace u by minus 1. Okay. Negative 1 to the power 3 is negative 1. Negative 1 to the power 2 is 1, so plus half. And negative 2 times negative 1 is plus 2. So 10 minus 4 is 6. And here, negative half plus negative 1 plus half is negative half plus 2. So that's 3 over 2 minus, there is a minus sign outside, and 6 is 12 over 2. So 12 minus 3, that's 9 over 2. And this would be the final answer. Let me check. Of course, you can check your answer. 8 plus 2, 10 minus 4, 6. 1 plus 1 over 2, that's 3 over 2. I can check even the original integral. 3u square plus u minus 2. Maybe I did a mistake or not. I need to check. Okay, from negative 1 to 2. The answer is 9 over 2, so that's correct. So you always can check the definite integral, but you have to write all the steps. Find the volume of the solid obtained by rotating the region bounded by the given curves about the line. So we need to find the volume here. And we studied two methods to find the volume. Disk and washer, and using cylindrical shells. So about which axis? About the y-axis. Well, about the y-axis, I can use two methods. Let me use, for example, cylindrical shells. Let me start by cylindrical shells. Well, the formula for cylindrical shells, if we are going to rotate about the y-axis, then we take a typical rectangle parallel to the y-axis. And the width of the rectangle would be dx. So the volume would be integral 2 pi x f of x dx and x from a to b, where x is the radius of the cylindrical shell and f of x is the height. That's the cylindrical shell formula method. Well, I need to sketch the graph of the area. Y equals x cube. I know how to graph y equals x cube, but there is a plus 1, so I'll go 1 unit up. If you put x 0, well, x equals to 0. If you put x 0, I'll have 1 here. Okay, and if you put y 9, so this is 1. If I say that this is 9, okay, if y 9, what would be x? I know that the graph will go like this, because this is the graph of x cube, you know. But I'd like to check if y is 9, what is the point? So x cube plus 1 equals 9, means x cube equals 8, means x is 2. Good. So I can say that this point is 2 and 9. Okay. And then this is the line, y equals 9. So if you look carefully, this is the curve, y equals x cube plus 1. And this is x equals 0. And this is y equals 9. So we are talking about this region bounded by all of these three curves. All right. If I'm going to use a cylindrical shell and rotate about the y-axis, I'll use a rectangle parallel to the y-axis. So x runs from where to where here? This point is 2 and 9, so x is from 0 to 2. 2 pi always there. If you rotate this cylindrical, this typical rectangle, you will get a cylindrical shell like this. Okay. Well, what is the radius of the cylindrical shell? The radius is always the distance from the rectangle to the axis of rotation, this distance. And this distance is always x. So I have x here. And f of x is the height of this rectangle. And you can see that the height, you have to find this, the length of this line segment. And the length of this line segment, how to find the length of this line segment? Okay, well, this is 9. So if I go, this is y equals 9. So from here to here, it's 9. And from here to here, it's y, because this is the point xy. So this is x again, and this is y. So the red line segment would be, which is the width, which is the height of the rectangle, the typical rectangle, would be 9 minus y. But I need it to be in terms of x, and y is x cubed plus 1. So it is 9 minus x cubed plus 1 dx. So this will give you the volume. And we can solve it. If you bring minus here, 9 minus 1, it is 8 minus x cubed. So this is 8 minus x cubed. And if you multiply by, you can take 2 by out. If you multiply x, distribute x, so I'll have 9. 9 minus 1 is 8. So I'll have 8 x cubed minus, sorry, 8x. This is 8 minus x cubed, and I'm multiplying it by x. So I'll have 8x minus x to the power 4 dx. And it would be 2 pi times 8x squared over 2 minus x to the power 5 over 5 from 0 to 2. And it would be 2 pi times, this is 4, okay, 4x squared. So if I replace x by 2, so it would be 4 times 4, so that's 16. And 2 to the power 5 is 32 over 5. And if you replace x by 0, you will get 0. So the final answer, you can use the calculator to simplify this. You will find that the final answer is 96 pi over 5. So that's the answer, 96 pi over 5. Or I can solve it using disk and washer. And if I use disk and washer, then I'll have to use a typical rectangle, which is perpendicular to the axis. So the axis here, axis of rotation, is y-axis. So I need a typical rectangle like this. So when I rotate about the y-axis using the method disk and washer, the formula in this case would be integral pi times, of course, dy. So y runs from C to D. And the outer radius. And the outer radius would be a function x of y, square it, minus another function x of y. So you have to write the interval as x equals g of y. This is the inner radius. So that's the formula. This is the outer radius square, and this is the inner radius square. Of course, when you rotate about the axis now, you get something, a disk, okay, a disk, and the formula is so I can evaluate the volume integral dy, of course. Y runs from where to where? Now y here from 1 to 9. So from 1 to 9. And the outer radius, to find the outer radius, you start by this, the axis of rotation, go to the outer radius. There is no outer and inner here. You can just, well, I consider the general case, you can just use one curve. So it's pi times radius square dy, because there is no outer and inner. It's a disk, in fact, it's not a washer in this case. So I need to write this curve, which is y equals x cubed plus 1. I just need to solve it for y. So x cubed would be y minus 1, and x would be cube root of y minus 1. So the volume would be from 1 to 9 pi cube root of y minus 1 to the power 2 dy. Because the inner radius is 0 here, it's a disk. That's it. Evaluating this, you should get the same answer, evaluating this integral. So I'll take pi outside. And now I have, inside the integral, I have y minus 1 raised to the power 2 over 3. And in fact, this is a linear function, y minus 1. So I know the integral. The integral would be y minus 1 to the power 2 over 3 plus 1, which is 5 over 3 over 5 over 3, or multiplied by 3 over 5, and over the derivative, which is 1. Derivative of y is 1. So from 1 to 9. So I can take, there is a pi also, do not forget the pi. So there is 3 pi over 5, keep this outside, and then replace y by 9. So I'll have 9 minus 1, which is 8 to the power 5 over 3, minus, replace y by 1, 1 minus 1, 0. That would be 0. Excellent. So we will have only this one. Well, 8 to the power 1 over 3 is 2. 2 to the power 5 is 32. And 32 times 3 is just 96. So 96 pi over 5 would be the answer. So I solved the integral for you, the volume, in 2 methods. So you can review both before the exam. The last question, set up but do not evaluate an integral for the volume of the solid obtained by rotating the region bounded by the given curves about the specified line y equals square root of x minus 1, 0, and x3 about the y-axis. So again, about the y-axis, and let us sketch the graph of these regions. Y equals square root of x minus 1, that's same as square root of x, but 1 unit to the right. So I can take it 1 unit to the right, and the graph would be like this. If you put x0, y, if you put x1, y0. So that's the graph. Y equals to 0 is this line, the x-axis, and x equals to 3 is this line, okay, the vertical line, x equals to 3. So this is the region we are talking about. We need to rotate this region about the y-axis. So again, I can use the 2 methods, okay? And the formulas are there, the formulas are here. So let me start by cylindrical shells. When I use cylindrical shells, I have to use a rectangle parallel to the axis of rotation, so a vertical rectangle. And this would be the radius of the rectangle, okay? The radius of the cylindrical shell, and this is the height, okay? So you can see that the volume would be equal to 2 pi, of course, dx, okay, because the width of the rectangle is x. X is from 1 to 3. And this is x, the radius of the shell, it's x. I don't need it. I don't need to change it because the integral is with respect to x. And the height of the rectangle, this is the function y equals square root of x minus 1. So it's in fact square root of x minus 1. So this integral will give you directly the volume if you use cylindrical shells. If I use wash disk or, okay, disk and washer, okay, then I have to use a rectangle which is perpendicular to the axis of rotation. So I have to use a horizontal rectangle. And in this case, I need the outer radius and the inner radius. And the outer radius would be this distance, and the inner radius would be this distance. And this point is x and y. So this is y and this is x. So the volume in this case would be the length of the rectangle is dy. So y is from 0 to this point. I'd like to know this point, okay, the coordinates of this point. Well, x is 3. So when x is 3, y would be square root of 3 minus 1, which is 2. So y is square root of 2, okay? Notice this is the region, this is the region, this is our region. So the highest y is square root of 2. Pi times the outer radius squared. Well, the outer radius is this red line. It is the distance from the curve, the outer curve, to the axis of rotation. This distance is 3, so when you square it, it's just 9. And then the inner radius squared. Well, the inner radius is this distance, which is x. And it is x of the curve, okay? So I need to change it to y. So I have y equals the square root of x minus 1. If I square both sides, I'll find out that x is in fact y squared plus 1. So this is the inner radius, and I need to square it and to write the dy here. So this is this also will give you the volume, and you can check your calculator. You will get the same answer. Notice that this major was up to section 8.3. Okay, section 6.3. Sorry, 6.3. Thank you very much, and hope to find you in another videos, and I hope you enjoyed this video.